Hello and a warm welcome back. Today on the bench is a transformer bobbin with a load of turns on it. This here is the first output transformer for the new amplifier, and already it's gone pear-shaped. Next morning now, got a load of turns on. Yesterday I got the first primary on, the secondary, and then started on this primary, the next primary. However, I wasn't very happy because the primary only covers from there to there, so we've got this like step and everything. And so what I was worried about, that the secondary that's underneath here isn't coupling over the whole of the area of the primary, if you're with me, over the whole of the core too. So I'm going to take this off and use smaller gauge wire but parallel it up. I will show you when I've taken this off. So now you can see what I mean. This is the secondary that I wound. 34 turns of, I don't know, it measures 0.8 of a mil in total. Don't know, I can't remember what it is. So that's got to come off. And then what I shall do, I'll show you in a minute. Right, I'm going to have to redo those, aren't I? I can find me thing. There we are. Yeah, what I shall do, instead of using this thick stuff, is to use a smaller gauge wire, but instead of just doing like, basically what I'm going to do is what I did on the mains transformer, which is to parallel it up. So put two turns on in one go in parallel. I'll show you. It'll all become clear, hopefully. And I've done my calculations. I'm going to use 0.63 gauge, 0.63 of a millimeter. I've worked out that two of those will do, I need 34 turns of the secondary. However, if I use that 0.63, I'll be able to get on 38, which will mess my ratio up a bit, but not too badly, I don't think. So unfortunately this wire is scrap. But I had an idea I would have to be doing some rewinding. If not like partial like this, then maybe the whole thing. Which I'm afraid, if you got your calculations wrong, is a distinct possibility. Some transformers that I've wound, it's taken me 3 goes. That's a lot of copper wasted and a lot of time wasted, obviously, if you're doing it by hand. So that's that off. She'll go and retrieve those tags in a minute, and then I'm going to have to redo my winding plan again, because I'd already cocked up yesterday. I calculated that I'll get 120 turns on across the full width. However, that was I was brushing basically, and that was for the first iteration that I calculated, meaning I was using thinner gauge wire. So what I've done, I've ordered some of this. I think it's 0.45, and I'll tell you in a minute. What is it? It doesn't actually tell me. Oh yeah, 0.45. Yeah, and I'd calculated for 0.375. But it just means that instead of the primary filling like the whole of it up, and I don't know if you can see, it sort of finishes about there. That was my first turn, but you know, never mind, we shall get there in the end. Regarding practical, you know, the practical side of it, as you can see, I've got like a tap coming out here. That's the end of my first primary, and as you can see, I've brought it out here on this edge rather than here. So if you're gonna do like bring out a turn, it's better to do it on this edge or like on the ends, but not in the middle, because if you do it in the middle, then all your turns, subsequent layers on top are gonna bulge out like that. Right, let me get my head on, because you really need to have your head switched on for this malarkey. Well, that's the first secondary started. As you can see, we've got loads of gaps. Starting a new winding is always difficult, so I always sort of start off, you know, a few gaps, and then we can nudge it up as we go. Try and get it neat. Always come back and, you know, like neaten it up when we've done. Just got to try and make sure this first turn is on right, and yeah, just carry on like that. It's not going on too bad. Some copper wire is more malleable than others. As you can see, we've got a bit of a twist going off there. This heavy gauge wire is really hard on the hands. I start getting cramp after a few turns, so it's a painful old process. Yeah, actually there's quite a few twists in there. I might need to get those out. Yeah, it's not easy, this game, at all. I'm using I'll just let that, using a cotton glove. I think Mike sent them all, maybe Alan, I can't remember. Yeah, keeps the wire clean, and it also saves the old fingers a bit. Right, I'm going to continue on. Well, that's the secondary redone. That's a lot better. That's covering the whole of the width of the bobbin, which is good. We've still got a bump there, but I'm hoping that when I put the primary on, which will like also end sort of midway, I'll try and fill that up further on up, if you're with me. So I'm going to put some Nomex on top of that, because that was a bitch to wind. Because I'm winding two at a time, the wires kept getting twisted, so that's took well over an hour to do that. As next time I shall know better. I mean, this is the thing with it, any experience that you get, you know, you make sure that you do it better next time, hopefully. Right, I'm going to go and cut the Nomex, have a cup of coffee, and then start on the long primary. This is the first layer of the next primary on. As you can see, I've bung some Nomex over the secondary. So this layer is, you know, winds good, because what I've found with so you've got a bigger gauge underneath, and so the wire, this wire here that would be on top of that, if we just use that, this thin insulation, then this wire will want to follow the wire underneath, if you're with me. So I was a bit adverse to using this Nomex. It's 0.1 of a mil thick. So what we need to try and do is obviously try to not have too thick a layer of insulation between primary and secondary, because then we get more capacitance. Right, and this is where I was here. This, I don't know if you can see it there, that bit of tape there, that's where I was last time. So that was the end, and you can see that we're going to get another couple of turns on there. We should get 103 turns per layer. Right, let me cut that off. And then it's continuing on. Right, well, I don't know whether to put some yellow insulation tape on top of this. Let me think. What we haven't got that much of a voltage differential, a potential difference. Where are we? Now, I mean, there's 300 volts across. God knows. Let me see. How many? About 7, maybe. Yeah. Oh, I remember. 22. There's 22 primaries. So there's 300 volts across 22 primaries. 300 divided by 20, let's say. What's that? 15. So there's 15 volts potential difference between each layer, I think. So yeah, I don't think we'll need any where do you call it, insulation. Right, I'm going to continue on because I really need to concentrate for this bit. As mentioned, the end is always a sod. Yes, I know I shouldn't be really using this, but I can't get in with anything else. Right, okay, it's fighting me. Hell's beard. Right, how are we going to do that? Alright, it's got to try and get behind that. Always difficult bits. Right. Come on, you absolute pig. Right, yeah. Right, I best go and sort this out. Part way through winding this primary, and as you see, we've got a little bit of funny business here, and that is where it sort of dips and transitions. As you can also see, I've got a bit of plastic on the plastic tape on the outside. That makes winding the first few turns easier. So I'm going to do the same thing here. I've had a problem trying to get all the spacing correct, and there's sort of a bit of crossing over of turns. So what I shall do, I shall just put a bit of plastic tape underneath there, which means pulling off a few turns, but then with the tape underneath there, the wire sort of adheres or sort of sits better on the tape. So right, I'll get that done. Sort of, you know, it is what it is. Really, what I should have done was designed it in such a way that there is no incomplete and partial layers, if you're with me, like this. But you know, I can't change it now without pulling it all apart, and I don't want to do that. Here we are, another day. Got 2 more layers to put on the OPT, and also the postie came this morning and brought me some lovely valves. These are from Billington in the UK. So these are our output valves, mostly sort of matched. Got a couple of military spec. That arrow is like the MOD sort of symbol, crow's foot arrow, whatever you call it. CB18, I don't know why they mark that. And then we have another 2 with VT61 on 10E1114442P. Yeah, Bobby Dazzlers, and bless them, they chucked in 1 free, different base, but I ain't complaining. And then these will be our cathode followers, drivers for the valves. I was really after 6 BL7s, but they'd run out of them, surprisingly. So these are sort of the next best thing. These are 6 BX7 GTs. I mean, really, you could make an amp with just these as the output valves. But yeah, they will drive the grids of these 2C34s easily at all frequencies. They will do when I've, you know, designed it. Right, I best keep winding then. Ho ho ho. As mentioned other times in this video, when you come to the ends, the last few turns, I find they're always a bit problematic. So I'm hoping if I line you best angle, I don't know if that's it. Let's try again. Right, as you can see we've got this remaining gap here, and as I go round it's smaller here than it is in other places. And also, it doesn't matter what you do, so what you're supposed to do is when you put the tape on, if you put tape on, oops, when you put tape on, you make sure that it sort of sits up. Not that much, obviously, I'm doing that for emphasis. Can you see there it's like going part way up the bobbin, which I'd done anyway to a certain point, so you know, yeah, I don't know whether it's a good idea to put insulation tape on every layer, because as mentioned, the potential difference between this winding and the one that comes on top is only about 15 volts. The enamel can take that. So with an output transformer, obviously we don't want too many great big thick layers like that, even though it makes the next winding on go on really nice, because of the you know, the capacitance that this causes. This basically acts like the dielectric in a capacitor, so we don't want too much of that. But apart from insulation, tape also does another job. It holds the windings on tight. I mean, they're on there pretty tight anyway, but it stops them rattling about and becoming noisy, because at certain frequencies, and especially at the resonant frequency of the output transformer, this thing will sing. You can hear it, you know, humming away like at about 10 kilohertz or whatever particular frequency it wants to resonate at. So what I do to sort of help, and I don't know whether this is a particularly good idea, you've seen me use this sort of, what's it called, it's fake rawhide. It's like a man-made, like sinew type looking thing. So if you twist it, you get like a round shape, and I've been putting that at the ends of the turns just to cushion that and to also fill in the gap, because obviously if we was to continue going up, all the windings subsequently on top will fall down. This is one thing I don't think that is mentioned. This is one thing I don't think is mentioned in a lot of videos. All this layer here, which is what, probably about the, how many have we had? I don't know, let's say it's the 12th layer. That, to a certain extent, will follow the one underneath that, the one underneath that, and basically the first winding that went on. The biggest cock up I made, as mentioned, is doing a partial winding there, because it's, every time I come to this sort of little step, it's made the turn to shit. So what I did on the last one, I used a bit of this thick, I think it's glass fibre tape, over that area, and then the turns on this winding went on better. So like I say, you know, having insulation on top of every layer isn't a good idea, as mentioned, because of interwinding capacitance, but also if you're not careful, that winding window will disappear fast. This stuff is 0.12 of a mil thick. 10 layers of that and you've got 1 mil. We've got 16 mil originally of window height, so yeah, you can see where it's going. And I did mention this in the video that I had about the Tektronix 585A transformer. Right, we are on 3,616 and we need to get to 3,716, so we need another 100 turns on, and that will take us back over here, and that will join on to the primary that goes on top eventually of the next secondary, if you understand me. How are we doing for window space? We had 16mm originate. I don't know what's going off. Holding the wrong bit. We've got 9.5mm left, and we are nearly halfway, so we're doing okay. I think we're doing fine. We've got one more layer of primary, another secondary, and then that will be just a tad over halfway. Right, shut up waffling, crack on. That's the end of the second primary primary winding. As you can see, I'm right up against the bobbin, and I've got one turn to go. So what I'm actually going to do, I'm not going to worry about that a couple of turns. I'd rather it sat well than what do you call it. So yeah, it's going to be a turn or so short. Bit of a bummer, because obviously we've got a gap here where I could have got it, and a gap there. So yeah, as mentioned several times, that frigging thing there, what I did there, has just really bugged things up. On the next one I'm going to do it differently. Right, I shall terminate that, label it, and then we've got the second secondary to go on, and then we are halfway there. We're about halfway there now, so hurrah! Come on! Whoop, 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 whoop. I'm ready to put the middle secondary winding on, and last time I cocked up because what I did, I'm using two lengths of this 0.63mm, and I wound it on a small bobbin, and that caused me no end of headaches because it just kept getting it just kept getting tangled. And so what I've done this time, and if you can see they're on the floor, just got two lengths of wire laid out, and I'm just going to let it drag in from the living room, as it were, past the door, and squeak over to the transformer bobbin. See you in a bit. Right, are you going to focus you? There we go. Got what, about 5 turns there on the next primary, and to celebrate, I hope we're going to get all this on anyway, to celebrate, as this old glove has got a bit mucky, I'm gonna don a new glove. Lovely. Smell that glove. Tastes good. Or does it smell good? Tastes and smells good. Let me have a taste. Bit chewy. I think I prefer curry. See you in a bit.